Nice to be here after many years with iSHARE. Good to see how this is growing. Frank Hermans, I've been in the global telecoms for a few decades, and about 5 years ago decided to start for ourselves with InnoTractor. And InnoTractor is about creating traction for innovation for our companies, for our customers, specifically in the supply chain and transport sector. Currently, we're implementing two data space setups. One is the project with container logistics for the Netherlands, all the containers from Rotterdam to the hinterland and back, 15 million a year, to provide actually a data space for all the administrative and booking services for that, together with the DIL and BDI setup. But today, I'm going to talk about Hyperion. And Hyperion is a project and data space we're implementing for the maintenance logistics part of the aircraft industry. Together with one step back. Together with the KLM and Ministry of Defense as the key driving forces for the setup. And we have partners in the setup with One Logistics, who's responsible for all the warehousing, for instance, on the F-35 program, and Elias, responsible for the planning of logistics in the defense industry. And together also with NLR, the Dutch aerospace laboratory of the Netherlands, as our ecosystem. As I said to ourselves, we're focusing on creating this optimization in supply chains. And today I'm going to focus about the case of Hyperion, not on the data spaces and everything underneath, but the business drivers beyond it. You had the question before, where's the business? I think that's a really fair question where we should be focusing on with each other, because that drives for optimization there. Once we have the data, we can actually optimize and go further. And that's our goal in life, really make sure that we have no waste anymore in our supply chains. So we give you a sneak preview of a demonstrator we're building together with the parties, how to actually standardize the maintenance, repair, and overhaul in the airline industry. KLM is KLM Engineering and Maintenance, I should say, is doing engineering and maintenance for KLM and Air France, of course, but also for 7 other major airlines on the global scale. And for each aircraft in the air, there's about a 6-fold of components on the ground. So you can imagine what kind of logistical challenge and transport movements and capital is involved to actually cater for this maintenance. So the whole goal is actually to optimize those number of transports, number of movements, reduce them significantly, and also reduce the stock necessary for the maintenance. And that's the real business case and business driver behind the whole setup. If you look at the 2 loops of Hyperion, the left loop is the operational loop, components in the aircraft flying around the globe. And the right loop is actually the maintenance loop. Once maintenance needs to be carried out on an engine or an oven or a rotor blade or whatever, then it is taken from the aircraft and goes into the maintenance loop. So those are the component life cycles actually that we want to capture. What's happening with the component from moment of delivery until end of life, and can we capture that digitally as well, and thereby actually be smart about our logistics. So if you look at an aircraft, it's as they say it, it's actually a set of components with a shell around it, and that's flying. That's how they look at an aircraft. And what we've been doing is actually give each aircraft, subsystem or component its own digital product passport. And that's what we're actually setting up now to actually manage all those digital product passports. And that means also that in the whole environment, all the parties involved in maintenance need to have access to the data. So it starts with the OEM, being Boeing, Aircraft, Embraer, who are delivering the components. Also logistics, One Logistics, who does the warehousing, and maybe Fokker Services, who does repair and overhaul, or all the other parties involved for the process. So there's an ecosystem of companies all looking for access to parts of the data relevant for their operations. And that's where a data space architecture comes in perfectly to actually manage this complex process. And mind you, today this process is still done very much on paper basis there. So this is really a major improvement to track the life cycle and from the life cycle actually also make the improvements. So how does this look like and how we're going to set this up? It starts with actually on the bottom right side all the measurements in the aircraft. There's a multitude of measurements on components, how they are performing. So we're trying to move to predictive maintenance where a signal is given to give maintenance to a certain component. And once the signal for or event for maintenance is being given, then actually the whole process will go to the MRO, the maintenance organization, look at the digital product passport and see where is it available, what are the measurements done, and how should I plan for the maintenance. That actually goes in this way. If you can see it, we have a live demo of the operational part of the data space, where the operator gives actually the signal for a specific component to implement a request for maintenance. That goes to the MRO operator, KLM Engineering and Maintenance, and they actually issue the order for maintenance to the different parties. And as you can see on the right-hand side, this is also monitored, the actual activities within the data space for all the logging and event setups. Because ultimately, airworthy certificates and airworthiness is the key driving force also for these processes, because we don't want to have our aircraft drop from the sky. So in the next step, the control tower then gets this request for maintenance, and they actually start planning. In their planning, they have to look, where is the airplane, at what moment is a hangar available, where are the components in the warehouse, can we get the components in time to a certain place to execute the maintenance. So there's a multitude of data sources to draw on to actually create a planning order for a specific tool shop to execute the planning. That's what's happening actually here in the control tower, and then the work orders are distributed to the tool shop, the transport organization, the warehouse for the components to actually execute that, so that the right component is on time at the right spot to execute the maintenance. And then, of course, when that is done and the aircraft comes in, the work is being done in the tool shop. They actually register all the work that's being done. And after the work is being done and registered, then the airworthiness certificates need to be generated. And then the aircraft can go back into service again and being handed over back to the operator. That's how such a process looks like. And this is a simplified version, I can tell you, because there's a lot more steps in between. But this gives you an idea of how the process works, where on the right-hand side, it's all about tracking and tracing of the actual physical components, the physical tracking and tracing. But on the, sorry, that was the left-hand side. On the right-hand side, actually also, how do you manage the whole process of the execution work order to actually back in service with the digital following of the contracts, where we're also looking to implement the smart contracts to execute this. And the goal of this process is also to actually make sure that in terms of governance, of course, AP and data ownership, but also the standardization of the digital product passports are being generated there. And of course, for the whole ecosystem, we want to simplify the way of working there. So for this project, we're setting up this project. It runs till 2028. And the real goal is to have not only the real demonstrated TRL 8, 7 ready for that, or even more if we can achieve it, but also with the partners and having Embraer, Boeing, and Airbus on board, create also a standard of data exchange and working in the airline industry to guarantee effectiveness and also safety in the aircraft industry. That is actually a presentation of a real working case we're working on from the business drivers that are there to really share data. If you want to look at it, there's a lot more going on. So keep following us, and I would also invite you to help us bring this to real life and a standard, because it will help also the Dutch airline industry going forward. Thank you.